All right, so what we're doing, if you forgot from last Thursday, is we are solving trigonometric equations. And what type of equations in general do we solve? Conditional equations. Conditional equations. We solve conditional equations. There are three other types of equations that we don't solve. So conditional equations are so called because they're only true under certain conditions, and we need to find the conditions. In other words, we need to find the values of the variable that make the equation true. All right, so example 10, it says to find all the solutions, every single one of them. That's going to be a task, such that this variable here, which some of y'all call pitchfork, but yeah, it is the Greek letter psi, PSI, pounds per square inch. Yeah, it looks like that. The psychologists like that because that's the first letter in the Greek word psychology, and they use that symbol for their club name, the American Psychological Association. That's their symbol. But anyway, we'll do the problem and then breathe a sigh of relief. See how that works? There you go. Yeah. Now notice this is very important on every single problem because that tells you where the solutions are. So we're looking for all the solutions in this interval, negative 4 pi to 0. And if you remember from last Thursday, I told you the easy way to find all the solutions regardless of what the interval ends up being. If we can find all of the ones in our comfort zone, and that's kind of a relative term, right? Some people are still not comfortable with it. But by comfort zone, I mean from 0 to 2 pi, within one positive rotation on the unit circle. Then all I have to do is modify those by adding or subtracting full rotations to get the ones I want. All right? So think about where negative 4 pi to 0 is. That's how many rotations clockwise? 2, right? So negative 2 pi would be one negative rotation. Another one would be negative 4 pi. So I want 2 negative rotations up to 0 and not including these. So that'll kind of inform what we do with our solutions once we find them from 0 to 2 pi. All right, so let's go to the equation then. The first thing that you want to look at in any equation is same thing as if you're doing this with the proof. Your angles have to be the same. And right now we're kind of limited. We have even odd identities and cofunction identities. But later on we're going to have composite identities and double angle identities. Are the two angles the same? Yeah, so that's step one. Step two then is you kind of take inventory. How many variable terms do we have in this equation? 2, right? We have a sine on one side and a cosine squared on the other. They're not like terms. So anytime you have more than one unlike term in an equation, your goal is to get everything on one side and set it equal to 0. That's step number 2 then, once the angles are the same. So I'm going to go ahead and subtract the cosine squared, and I get minus 2 cosine squared of psi, and now it equals 0. So if you have more than one term and they're unlike terms, get everything on one side and set it equal to 0. Now the whole purpose of setting something equal to 0, remember, is to factor. What's the first rule of factoring? Common factor. Yeah, do we have anything common besides 1 or negative 1? I don't see anything common besides 1 and negative 1. We can't factor out the psi, can we? Because it's inside the angle. So here's where you have to then make a decision. We need to get this entirely in terms of either sine or cosine. It doesn't really matter. So let's think of the options here. Is it easy to turn a sine into a cosine without changing the angle? I could use the cofunction identity, but that would make this pi halves minus psi, and that's not good. Is it easy to turn a cosine squared into a sine squared? That's a lot easier, okay? So using Papa PID, that's what we're going to do. And anytime you make an identity replacement, I would highly recommend putting parentheses around that thing that you're going to be replacing, especially if there's something out front like a negative 1 or in this case a negative 2. All right, so here we go. We got 3 sine of psi minus 2 parentheses. And what is cosine squared in terms of sine squared? 1 minus sine squared. Yeah, that should be kind of getting a lot easier for you. Shouldn't have to look it up or anything. And now we'll distribute. We'll expand it out. So we get 3 sine of psi minus 2 plus 2 sine squared of psi equals 0. So now the angles are the same. That's good. And I have everything in terms of sine, which is good. but there's still nothing common here because the middle term doesn't have a sign in it. But what you do notice is something from Thursday. We have a squared term, a non-squared term, and a constant. And so that could be a factorable trinomial. So let's go ahead and rearrange the terms. We'll write it in descending order. So we have a 2 sine squared of psi plus a 3 sine of psi, and then minus 2 equals 0. So just as if this were like a 2x squared plus 3x minus 2, it might factor into the product of x plus or minus something, x plus or minus something. The same thing goes for this. The only difference is we have sine of psi instead of just plain old x. Now this is the fun variety, remember, because the leading coefficient is not 1. But it is prime. It is 2. So the two factors in the front have to be a 2 sine of psi and a sine of psi. That's the only way that thing can factor. And of course, it doesn't matter which one's a 2 and which one's a 1 at this point. The constant at the back is a negative 2, which is also prime. It only factors one of two ways. But I need to be able to pair it up with the 2 so that I get a positive 3 out of the middle. So however you like to factor these types of things, guess and check. Trevor has a way. You can split the middle term, whatever you want to do. Just factor it, okay? It's going to factor like that. Now, I would always recommend checking, right? Your first is going to give you, of course, 2 sine squared of psi. Your last gives you a negative 1 times 2, which is a negative 2. So if you check the middle terms, you're going to get a 2 times 2, which is a 4 sine on the outside, minus a 1 sine on the inside, and 4 minus 1 is positive 3. Okay? So it factors just like it would if it were just x. So now that it's factored, now we set each of those equal to 0. And it almost seems like we're creating twice as much work for ourselves. We have 2 equations to solve instead of 1. But that's fine because each of these now are easier to solve. All right, so here's the other thing. Once you have an equation with only one variable term, then you don't want it to be equal to 0. Now you want to isolate that term. So each of these then have just the one variable term. You want to get the sine of psi by itself. So over here, if you add 1 and divide by 2, you get sine of psi is equal to a half. And on the second one, you get sine of psi equals negative 2. Now, if this were x instead of sine, we'd be done. We have x equals a half and x equals negative 2. But in this case, we have sine. So this is where the fun part comes in. We get to use the unit circle. And if you're solving these equations and I don't give you a calculator, they're going to be nice unit circle ratios. So now, in our comfort zone, where is sine equal to 1/2? We're taking the inverse sine operation, not the inverse sine function. Pi should be pi 6 in quadrant 1, and where else? 5 pi 6, good, in quadrant 2. Now, those aren't my final answers, remember. Those are just the 2 between 0 and 2 pi. I'll modify them here in just a second. Where is sine equal to negative 2? Is that going to happen? Think of the graph of sine. No, sine oscillates, remember, between 1 and negative 1. Negative 2 is not going to ever happen. So there's no solution to this one. So not every piece is going to generate solutions. But we do have 2. And now we'll answer the question. So psi is going to equal, let's take our pi 6, and I need to then subtract 2 full rotations. So if I subtract 2 pi, what's a good version of 2 pi to use here for counting by 6? 12 pi 6, right? 12 pi 6 is the same as 2 pi. So what's pi 6 minus 12 pi 6? Negative 11 pi 6. And then we'll do it one more time. What's negative 11 minus 12? Negative 23 pi 6. Good. So all I did is I took my first solution of pi 6, and I subtracted a full rotation twice, and I wrote it down. And then we do the same thing for the other solution. I'll use a different flavor here. 5 pi 6, if we subtract the full rotation, 5 minus 12 is negative 7 pi 6. I do it one more time. Negative 7 minus 12, negative 19 pi 6. There you go. And so there's the 4 answers that satisfy the equation between negative 4 pi and 0. And just in case you weren't here on Thursday, remember there was another way. I could have asked what are the solutions in general for all of them. And remember, in that case, you would find these two, and then at the end of each one, you would just say plus 2 pi n, right? So pi 6 plus 2 pi n, and 5 pi 6 plus 2 pi n. And of course, when n is an integer, you can add or then subtract any multiple of a full rotation to generate all of them. Okay, so quadratics. Got to get the angles the same, then you got to get the trig functions the same so you can factor it. Okay, sigh of relief. So that kind of captures all the different strategies. We're very limited right now because we don't have that many identities. They do get increasingly fun as we progress through the next few sections. So on example 11, we're kind of putting it all together, kind of mixed practice. It says rapid fire, but maybe rapid fire in the term of like muskets. Okay, can you rapid fire a musket? I guess you could be a really quick musket loader and be the fastest musket loader in the world, but in terms of like